So this is my second video on C2 from AQA GCSE Science. So in the first video I talked about bonding, which is also on the same playlist as this, and in this video I talk about properties. So substances that consist of simple molecules are gases, liquids or solids that have relatively low melting points and boiling points. So if it's a simple molecule, they've got a low melting point and a low boiling point. So this bit in bold is just for the higher tier students, and that's where substances that consist of simple molecules have only weak forces between the molecules. So they have a name for these forces, and they call them intermolecular forces. So the intermolecular forces, so in other words, the forces between the molecules, are weak. Those are the forces that are overcome when you're trying to melt or boil a molecule, not the covalent bonds. So the covalent bonds, so the bond between the hydrogen and the oxygen, let's say, that is not what they're trying to overcome. They're trying to overcome the bond between one H2O molecule and another H2O molecule. Substances that consist of simple molecules do not conduct electricity because the molecules themselves have no overall electric charge. So there's no ions there, therefore they do not conduct electricity. Ionic compounds have a regular structure, so they have this giant ionic lattice, and there's strong electrostatic forces in all directions between oppositely charged ions. So I mentioned that in the last video about bonding. So these compounds have these high melting points and high boiling points because it takes large amounts of energy to break these strong bonds, and because there's so many of these strong bonds, it requires such a large amount of energy. So there's lots of strong ionic bonds that need a lot of energy to overcome them, therefore it's a high melting point and a high boiling point. So when we melt or dissolve in water ionic compounds, they can conduct electricity. This is because these ions that are there within these bonds are now free to move and can carry the electric current. So remember, current is just the flow of charged particles. The ions in these situations are the charged particles. So when you melt or dissolve these ions in water, these ionic substances in water, ionic compounds in water, then they can actually carry current. Atoms that share electrons can also form giant structures or macromolecules. So we're talking about giant covalent compounds here, and there's three main ones that you need to know about, or giant covalent structures. Diamond, graphite, both of those are made from carbon, and silicon dioxide are the three main examples. All of these structures are linked to other atoms by strong covalent bonds. So they're very, very high melting points. So there's like a repeating structure within these, thus the idea of a lattice. Okay, and it's a very, very strong structure. High melting point, high boiling point. So let's take diamond first. Each carbon atom forms 4 covalent bonds with other carbon atoms in a giant covalent structure. So diamond is very hard. Okay, it's got a very high boiling point and a high melting point as well. But it's the fact that each carbon bonds with 4 other carbons. Okay, graphite is made in layers. Okay, so these layers are literally one on top of each other, and they can slide over each other. The way you can tell it's graphite is by identifying those layers, but also the fact that each carbon is bonded to only 3 others in this situation. The layers are free to slide over each other because there's no covalent bonds between the layers, so it's soft and slippery, and that's why when you write with a pencil, the layers of graphite come off. Interesting enough, graphite also has 1 electron from each carbon atom, which is delocalized. So in other words, it's not involved in any of the bonding. So these delocalized electrons are free to move, and therefore they allow graphite to conduct heat and electricity well. Okay, carbon can also form fullerenes with different numbers of carbon atoms. Okay, fullerenes can be used for drug delivery into the body, in lubricants, as catalysts, in nanotubes, or for reinforcing materials, e.g. in tennis rackets. Okay, and they do like to ask about tennis rackets quite often, and nanotubes. Okay, so that's just a statement that you need to know if you're a higher tier student. Remember, the 2 bolds are for higher tier students. Right, metals. So we talked about ionic compounds, talked about covalent compounds, talked about them in terms of giant structures. Let's talk about metals now. So metals conduct heat and electricity because of the fact they have delocalized electrons. Again, that's a higher tier point. Remember, the layers of the atoms in a metal are able to slide over each other. That was mentioned in that first video. So this means that metals are malleable. They can be bent and shaped. Alloys are usually made from 1 or more different sized metals. The different size of atoms of the metals distort the layers in structure, making it difficult for them to slide over each other. So it makes alloys harder than pure metals. Let me sort of draw something here so you can get your head around this. So if I've got a pure metal here, like this, those layers will slide over each other because all the atoms are the same size. So that's a pure metal. That is what a pure metal looks like. These layers can slide over each other. If I was to make this an alloy, I'd add like different size atoms in here as well. So by adding these smaller atoms, that actually prevents the layers from sliding over each other. So if I've got atoms of different sizes within there, different size atoms, the layers are now distorted, and therefore the layers don't slide over each other, and therefore that makes alloys harder than pure metals. You do get these special type of alloys called shape memory alloys, and they can return to their original shape after being deformed. Okay, so nitinol is used in dental braces, so things like heat or pressure, it can actually return these to their original shape once they've been deformed and out of shape. And the last bit I want to talk about in this video is about polymers and nanoscience. Okay, so there's two main types of polymers that we actually need to know about. Two groups of two types. So there's low density and high density, which we'll talk about in a second, but also thermosoftening and thermosetting. So let's go with low density and high density first. The properties of polymers depend upon what actually they're made up from, and also the conditions from which they're made. So low density and high density polyethylene are produced using different catalysts and different reactions. So the key point to get out of this is that different conditions and the monomers that we're using in the first place will actually affect the properties of the polymer. So what a polymer is made up from affects its properties, and the conditions used to make the polymer affects its properties. Thermosoftening polymers are individual tangled polymer chains. So they're individual. Okay, thermosetting polymers consist of polymer chains with cross links, so they're stronger. Okay, so that they do not melt when they're heated. Thermosoftening, heat when they're melted. Thermosoftening, soften upon heat. Thermosetting, do not soften upon heat because of the cross links. So thermosetting have cross links, so they cannot be melted. Essentially, they cannot be. Their structure cannot change with heat. Thermosoftening can be changed with heat because of the fact they have tangle change with no cross links. Nanoscience, okay, so that refers to structures that are 1 to 100 nanometers in size. So whenever we talk about nanometers, that's 10 to the minus 9. So times 10 to the minus 9 is what we're talking about. That's what nano stands for. So that's a decimal place with 9 zeros after it, essentially. So that's a few hundreds of atoms, okay? Nanoparticles show different properties to those of the same material in bulk, so when there's a lot of it, because they have a high surface area to volume ratio. Now that is their key point for this, that the fact they have different properties, mainly due to they have a high surface area to volume ratio. That is key. This means that we can make new computers, new catalysts, new coatings, new sensors, stronger, lighter construction materials, new cosmetics. So suntan creams and deodorants, they all use this idea that has a higher surface area to volume ratio, and therefore they're more effective at what they do. Alright, thank you for watching this video.